Hi everyone, let's take a look at another application of linear systems, and this time we're looking into mixture problems. Now, mixture problems are the ones in which two different solutions are mixed to create a resulting or a final solution. I strongly encourage that we use a table to organize the information. It will help us to organize the information effectively and solve the problem efficiently and with no mistakes. Now, I'm going to explain how we set the table up. Let's read the problem first. A chemistry teacher needs to make 10 liters of 42% sulfuric acid solution. Okay, so 10 liters means volume, and I'm going to write this down, and 42% means concentration. So the meaning of it is that if we have a sulfuric acid solution, part of the solution will be pure sulfuric acid and part of it will be water, because sulfuric acid will make only 42% in this case. So if you have, let's say for example, if you were to have 100 liters of a solution, and let's say 40% of the solution will be, let's say, salt, right? Then 60% is going to be water, all right? So the same idea applies here, and I took this example because it's kind of more practical and everyday kind of thing. Now, the acid solutions available are 30% sulfuric acid and 50% sulfuric acid by volume, because we're using volume in this case. We're not using mass. That's what the meaning of by volume. That's why we say here by volume. Now, how many liters of each solution must be mixed to make a new solution of 42% in concentration? So as you can see in here, we're mixing 30% with 50%, so lower and higher, to make a 42% solution, which is, as you can see, between 30 and 50. And that's common sense when you think about it, right? So when you mix a lower with higher concentration, a solution, you're going to create a solution that has a concentration in between. Now, what I want you to think is, at this point, is what do you think? Like, use your reasoning, your logical reasoning, to create a 42% solution from 30 and 50%, right? So, would you say that you used more of 30% or more of 50%? Okay, so think about it, and we're going to revisit this idea at the end of the problem after we solve everything. Now, how many liters of each solution must be mixed to make the 42% solution? So focus on the question asked. We're asked to find the liters of each solution, so that means the volume of each solution that must be mixed to make the 42%. So each solution, we mean the 30% and the 50% solution. So what we're going to do is we're going to let X be the volume of, X be the volume of the 30% solution and Y be the volume of the 50% solution. We know that we're making 10 liters of it, so the total mixture would be 10 liters. Now, the next thing that we want to do is calculate the amount of pure sulfuric acid. So remember, as we explained, if we have, let's say, 42% sulfuric acid in 10 liters, not all 10 liters will be sulfuric acid, only 42% of this volume. So in a similar way, if we have 30% sulfuric acid, not the entire volume will have pure sulfuric acid, but only 30% of this volume, which volume? Volume X, right? Will be sulfuric acid. Now, it is very important that we write this as a single term. We already know that 30%, that's not a real number. It's just a way to describe a quantity. So we have to convert percentage into a decimal. And percentage into a decimal would be 30 divided by 100. We know that of means multiplication. And then we have X. So 30 over 100 times X will be pure sulfuric acid, and that would be equal to, divide 30 by 100, you get 0.3X. In a similar way, we're going to visit the volume Y liters of 50%, and we're going to say that 50% of Y liters is going to be 50 divided by 100 times Y, which equals 0.5 Y. Now, the amount of pure sulfuric acid in the final solution is 42% of 10. So now we're going to say 42% of 10 liters would be 40 divided by 100 multiplied by 10, which is equal to 0.42 times 10, or even further, equal to 4.2. So now, as you can see here, we have defined the volume of each solution that we are using, and we know the total volume, and we know the amount in volume always of pure sulfuric acid in each solution and the amount of pure sulfuric acid in the mixture. So that is going to be 42% of 10, so 4.2 liters will be sulfuric acid, pure sulfuric acid. So I think we're now ready to create the equations. We know that the total volume is going to be x plus y equals 10. So we're going to set up our first equation. And the total amount of sulfuric acid will be 0.3x, which is pure sulfuric acid from first, plus 0.5y, which is the amount of pure sulfuric acid from the second solution, would be equal to 4.2 liters. So as you can see, we have created our two equations that we need for the system. So we're going to put them together in a system of equations, and voila, here is hiding the solution to our problem. And we know how to solve these systems. Remember, this is one with decimals. So what we're going to do is we're going to try to convert the decimals into smaller numbers and whole numbers, and we're going to have our integers more precisely. And since we have the numbers to one decimal, we're going to have to multiply by 10 everywhere. And we'll have x plus y equals 10. 3x plus 5y equals 42. Remember that every single term gets multiplied by 10. You don't necessarily have to use a calculator here. You know, multiplication by 10 will remove the decimal place by 1 to the right. Now, I'm going to have to think, do we want to use substitution? Do we want to use elimination? Elimination is my favorite way normally, but I'm going to go for substitution this time because I'm very tempted by these, almost isolated variables. I'm isolating y from the first equation, so 10 minus x, and I'm going to put in that y in the second equation, so 10 minus x instead of y. That is right here, and that equals 42. We're going to solve this very simple equation, linear equation together. So that would be 42. 3x minus 5x is negative 2x. So right here. And on the other side of the equation, we'll have 42 minus 50. 42 minus 50 is equal to negative 8. X would be equal to negative 8 over negative 2, or x will be equal to 4. So if x equals 4, knowing that x plus y is 10, we're going to say y equals 10 minus x, or 10 minus 4, which is 6. Now recall that x is the volume of 30% solution, and y is the volume of the 50% solution. So therefore, we're going to say that 4 liters of 30% sulfuric acid solution and 6 liters of 50% sulfuric acid solution were used to make uh, 10 liters of 42% sulfuric acid solution. Let's write it one more time. All right. So now let's go back to the question we posed at the beginning of the lesson. So what did you think we would use more? Would you use more of the 50% or 30% sulfuric acid? Well, obviously, we see that we use more of 50%, but why? And how can we figure out? Because that can help us actually justify or understand whether our answer makes sense or not. So, since between 30 and 50, there are 20 units, which means that if the solution had a concentration of exactly 40%, which is right in the middle between 30 and 50, then we would have probably taken the same amount from each, so 5 and 5. But because this is higher than 40%, then we have used more of the higher concentration. And it's always good to actually think beyond the information you're given and try to understand how the connections practically, exist between the numbers, the values, the variables in a problem. So I hope these explanations made sense. I invite you to practice more mixture problems on your own. You have a lot of practice questions posted online, and the more you practice, the better. Thank you for learning with me again, and bye for now.